mean average temperatures for May from 1948 through present. 2020, which isn't even done, is already in the top 6 as far as high temperatures. So our average high temperature for Tucson this month is 79.2, and the all-time high is 80.2. So we're in striking distance of being the warmest May on record. And it's just how the calendar falls, is when this heat event actually occurs and when it gets logged could push us up over into that record territory. We're in striking distance as it is already. Okay, so the upcoming heat event is, again, interesting. It looks very similar to the pattern that we had seen in late April and early May, and it's something called an omega block. And it's that same getting squashed between a low pressure system, and you can see this upper panel here is a weather map forecast for Friday. And there's the blues up over northern upper peninsula of Michigan, kind of north into Canada. This is a big trough of low pressure. There's even a little bit of blue over Alabama here. So that's this broad, long trough here. And then there's a really deep low pressure system off the California coast. And if you notice the ridge of high pressure, which is this red area centered over Utah, it almost looks like the Greek letter omega. And so that's tracing out that pattern of an omega. And so that becomes a blocking pattern. And so when you get an omega block, the atmosphere tends to start to kind of grind down on itself and slow down. So when you get omega block patterns, they typically don't move very quickly off to the east, and they can really ratchet down and drive up temperatures. So the bottom left here is the forecast highs for Tucson, and this has been updated and kind of tweaked a bit, but it looks like 107 on here, and Marana is 109. And these could go up or down slightly with some adjustments as the forecast comes there. And you can see the broad map here on the right, that this is 10 to 15 degrees above average for this time of year. The normal high in Tucson for the end of May is 95. So if we go to something like 110, that's 15 degrees above average. And it's also interesting to note here too, is that it's cooler than average over Texas, and then much, much warmer than average over us because of that strange circulation pattern that we see in that upper weather map. Okay, so this is one last longer term plot here that I pulled up. I was curious, like, what in each year since 1948, what is the maximum temperature recorded at Tucson Airport? So this is in every year since 1948, what was the hottest day of the year? And so this is a plot of that, and you can see here that the hottest year on record was 1990 at 117, and there's this kind of cluster of years from 1988 to 1995 with a kind of a respite in the middle there, where we had a couple of really screaming hot days, and then we've really hung out pretty regularly, seeing at least a 110 degree day for the last couple of decades. And then there is 2017, which almost broke. I don't know if anyone remembers that June was Father's Day weekend. Very, very hot conditions, record hot. If you went down to say like Yuma, pushing 118, 120, I think was even recorded around Yuma. And then the last couple of years we've tailed off. And so this is through May 26th. So it'll be interesting to see what does May and June have in store for us, because we typically see our record high days sometime in that, usually in June, sometimes in July if the monsoon's late, but as soon as the monsoon comes in, it takes all of the energy out of those high temperatures and just turns it into that sticky humidity. So the overnight temps come up, but the high temps in the day aren't able to get quite as high because we get clouds and convection that come into the system. Okay, so what does the outlook look like for the next 2 weeks, which puts us into almost striking distance for the official start of the monsoon, which would be June 15th, which is really too early for real monsoon activity, but we're getting into that window. So what we see on the 8 to 14 day outlook is a real strong chance of this big dome of high pressure over the entire continental US, and it's shared, but it looks like it's going to kind of shift off to the east just a little bit. And as it does, it's letting some moisture from the south, very, very early monsoon moisture. It's not really technically monsoon season moisture yet, but it's subtropical moisture coming up from Mexico start to sneak up into New Mexico and into the Tucson area as well. So there's actually a chance of thunderstorms next Monday. And so the interplay with that is if we're starting to get moisture into the region, it's going to really take the chances of extreme high temperatures off the table, but it'll trade it with that sticky weather, which has its own kind of bioclimatic issues with it too, where swamp coolers don't work as well and all of those issues. So it's just sort of it's not any more comfortable. It's just a sort of a change in that discomfort. And again, if we look under the hood of that forecast, that's the weather map for the end of this period. So this will be out towards June 10th. And there's that big ridge of high pressure over the middle part of the country, that kind of the heat dome, as you'll hear it kind of referred to on the Weather Channel. And there's this kind of blue area over the Gulf of Mexico. And the Gulf of Mexico is already busy with tropical storm and hurricane activity. So I think the outlook for an enhanced or active season for the Gulf looks really strong and solid. And that can have implications for Tucson and New Mexico much later in the season. You can see hurricanes actually drift all the way across northern Mexico into us, but it's really kind of an outside shot at that point. Okay, so kind of finally, the last graphic here is the temperature outlook for July, August, and September. The upper left image is a very solid, very confident, above average forecast for all of Arizona. And that is because we have very strong trends in summer temperatures. And so if you're going to make a forecast for above average, average, or below average, if you've got a strong trend, you're basically using that trend to make a forecast, and you'll be right more often than not. So that's really where that forecast comes from, this trend. And the lower right is a forecast for the precip. And you'll notice here, most of Arizona, except the Four Corners, is in what we call equal chances. That means there's equal chances of a below average, average, or above average, which means no forecast. And so it is a I heard the Climate Prediction Center said they're very confident in their no confidence forecasts. So that to me there's some buried information there, I think. So I think this monsoon season, we'll just have to wait and see. There aren't real good indications of it either going awry or being gangbusters. So I think we'll just have to wait till the end of June to see how things are shaping up. So that's all I have, and I'm absolutely happy to answer any questions, and they can be on this stuff or anything else that I can try to answer.
Okay. So participants, I can't see you. What are you? There we go. If anyone has their mute off and they would like to ask a question, we did get a question. We got a text question from Mary. And she asked, why would some of the data be shown as missing at the airport? That was an earlier slide.
Oh, that's interesting. Yeah. So this particular slide, if it was these right here, these just haven't occurred yet, because this is through May 18th. And the data hasn't caught up on this particular plot. Let me see if any of the other years have any missing data. I may have had one missing data here. Sometimes it's interesting, the way that the data come into the airport, I pull the data from the National Climatic Data Center, and there's a big data transfer process from it going from the National Weather Service here over to Asheville, North Carolina. And sometimes it takes months for even one data point to get all the way through the process and into the final data set. And so that could be that I just didn't update the plot. I'm sure it's in there now, but I may have just missed it when I made this plot.
Okay.
Karen, are we supposed to raise hands for questions?
Well, I can't see any of you people.
Oh, you
I don't know why I can't see you. Just go ahead. Please
All right.
go ahead, Des.
So my question, if you talk to a lot of people, I've only lived in Tucson 10 years, and people tell me there used to be a lot more frequent monsoons. And I know that kind of information isn't very reliable, confirmation bias, et cetera. So has it decreased? And if so, or just in general, what is the relationship between increasing temperatures and frequency of monsoons?
Those are really good questions. Okay, let me try to take it one by one here. So there have been numerous studies looking at precipitation data that we have in these historical records, like the Tucson station, that range anywhere, that the good records go back to, say, the 1930s to present, and then we've got a lot that go from 1950 to present. And so if you look at those good, solid precipitation records without a lot of missing data, you don't see real good systematic trend in either increasing or decreasing monsoon precipitation. And so this is kind of a hot area of research, because there have been a couple of papers that have come out and said, you know what, it actually is decreasing, but it's not very compelling evidence, and that there's been an increase in the intensity. And then there was a recent set of studies over at Walnut Gulch, which is an agricultural experimental watershed out by Tombstone. It's one of the most heavily instrumented watersheds in the world, and they've been collecting hourly, sub-hourly precipitation measurements in every square kilometer in this watershed since at least the 1960s, and they have some data that goes even back to the 1930s. What they found was that they had detected in their data set an increase in the intensity of monsoon season precipitation. So you get all these different answers when you carve the data up in different ways, and you look at different regions of the monsoon. So when you average it all together, you see basically no real systematic change, just a lot of variability and a lot of noise. And it's probably because we don't have enough rain gauges with long enough records and in the right density to be able to detect the changes, because the monsoon season is so noisy from year to year and over space. I mean, you've seen those storms in Tucson where they're raining 3 inches on one corner of town and it doesn't rain at all at your house. Like, that's pretty normal. And so detecting changes in that is really, really challenging. So sorry, go ahead.
I have a question about that. Is the data that's not showing a clearly and dramatic trend, is that based on rainfall at the airport or what?
It's one of the data sets, but most of the studies have been using as many rain gauges as can be gathered. And so they will be at airports across the region. And then there's also a data set called the NOAA Cooperative Observer Program, which is the legacy historical data set in the United States. And it's collected by observers, cooperative observers. And it used to be farmers and ranchers who would set up gauges in the early 1900s and would read them every morning at 7 a.m. And that has largely disappeared. And now it's at parks, it's at experimental farms. And so we've got that data set, and that's kind of a mishmash of locations and missing observations. So when they do these studies, they'll look at as many of those data sets that they can kind of cleanly bring together as possible. So it's not just one day, not one station that anybody's kind of driving any trends from.
Okay, I'm just curious because I'm one of those people who would say I have anecdotal evidence. I moved to Tucson in 1980, and when I was in grad school in the early 80s, there was no way anybody would start to walk or bicycle home in late afternoon during the monsoons, because it rained almost every day in Midtown Tucson.
Yep. Yeah,
and I totally agree with the less consistent and more dramatic.
Right. Yeah. But, so if you look at these records, you'll find discrete blocks of time where the monsoon is it's solid and gangbusters and does the same thing for a period of years, and then it'll have another block where it's a mess and it doesn't do anything like it used to, and then it goes back to either goes back to something or does something new. So if you kind of look at it in totality, it doesn't have real good discernible. It's almost like, this question of what does a normal monsoon look like? And it's really hard when you start to plot up the data to even make sense of what that might be. Like, we've got real kind of rough thing. It generally starts around July 4th, and it almost always comes in either 2 weeks before that or 2 weeks after. That's kind of the error bars. That's pretty reliable. But then how it evolves over the rest of the season becomes this mess of, are there tropical storms in the East Pacific? Are there hurricanes that are decaying and moving across the Gulf of Mexico? Is the ridge position waffling around the Four Corners High? Is there something else going on in the North Pacific? And then even under those, if those are all in the right spot, it may rain at your neighbor's house instead of your house.
Yeah, thank you.
Yeah, absolutely. Great question.
So the heat, relationship to heat,
Mm-hmm.
presumably that would would that explain increase in intensity?
Yeah.
And
So
an effect on frequency.
right. So that's the hot question in the monsoon research community right now is trying to model forward what the changes in the monsoon system might be, and they've kind of there's pretty big uncertainty around what is happening. So the increased temperatures have led to a detectable increase in the hydrologic cycle and the amount of humidity in the atmosphere, which has led to discernible increases in precipitation in certain parts of the world. Like if you look at like the Northeast United States has a pretty discernible increase in precipitation intensity. That's you can really link back to a climate change signal. When you go down here, you end up getting this really muddy signal where thermodynamically more water in the atmosphere could certainly mean heavier precipitation amounts, but it's at this tug of war with increasing temperatures might actually lead to a more stable atmosphere. It's just actually harder to generate convection. And the models have kind of gone in two different directions with which aspect will win. If it gets much, much wetter here in the future, like a really much more humid, we get a lot more access to moisture, then you could see the monsoon actually strengthen and have more precip events and heavier events. But if it's at this tug of war where as it gets warmer, it balances out that humidity change and it just gets generally less convectively unstable, and then you end up having weaker monsoons and less precipitation. And then it would just be hotter here during the summer, which would be, that is the worst case scenario in my mind. It becomes more like, Tucson becomes more like Phoenix because it's really hard for Phoenix. Phoenix only sees at best 2 inches of rain during the monsoon season, and Tucson sees 6. That's, you know, it's almost 3 times as much rain, and we're not that far away. It's because we're a little bit higher elevation wise, we're closer to the moisture, and we've got mountain ranges that help focus the precip.
We have another question.
Thank you.
How did the site at Tombstone end up being so heavily monitored? Why there, and who is doing it?
That's a great question. So it is a U.S. Department of Agriculture experimental watershed. I believe it was established in the 1930s, and I think it was in response, and again, I'm kind of making this up. This is I can vaguely remember the story here. Definitely look it up on your own, but it was developed in response to a lot of erosion that was occurring across the West, in the Southwest in particular, kind of it was post Dust Bowl or even kind of concurrent with the Dust Bowl, to try to study soil stabilization practices. So they needed a lot of rain gauges, and they still do this work on looking at rainfall runoff and soil erosion practices there. And they do a lot of other really cool global change type studies, lots of instrumentation, and you can actually go tour it too. It's really cool if you're kind of into that data collection kind of stuff.
What's the site called again?
It's the Walnut Gulch Experimental Watershed, and it's a USDA Agricultural Research Service site.
Still in a drought? I mean, what is a drought here? But are we still in a long-term drought, or are we out of it, or what's the definition of a drought here?
A great question. So I think in terms of drought in the Southwest as being, it depends on who you are and where you are and what you're talking about, because and largely that translates into, you can have droughts of different time scales. So I think on short time scales, meaning, you know, have you had enough rain over the last 6 months to meet plant water needs, or even generate some bit of runoff and recharge, you know, smaller streams, that we have done really quite well with last winter and this winter. So I would suggest that we're out of short-term drought conditions. There's all these caveats though. Last summer was not a great monsoon. It wasn't quite a failed monsoon here, but it wasn't great.
Yeah.
And so if you are an ecosystem or you're an agricultural producer, or a stream that relies on summer precip occurring at the right time, there's a drought impact that actually occurred last summer that won't be solved until we get through this monsoon season. So you've got the timing of the precip at play. So that's all short term. If you look at like 5-year moving windows of generally average conditions, then we're probably not, because in the last 5 years, we've had more drier conditions than wetter conditions. And if you look at the last 10 or 15, that longer term period is very dry relative to the historical record and has not been solved by any of the recent precip. We need to end up having 5 more years of above average winters to really pull us out of a longer term drought. And those are hard to come by in the historical record. And so this is where you get this kind of noise or conflation between, you can have a mega drought, as has been kind of talked about in the news. That's certainly a way of thinking about it. But what that's really talking about is a longer term drought that's affecting water resources. And at the same time, you can also have no drought because you've had the right amount of precip at the right time of year, depending on that system. So it's kind of complicated.
Yeah, it is. There was some study out of, I think, Santa Barbara that the Navajo Nation was in a drought that was absolutely caused by climate change. Do you recall that? It's a couple months ago.
Yeah, I did. I saw that too. Okay, so this is another complication, is that there's now this kind of mashing together what I would consider aridification, which is it's getting warmer, it's driving more evaporation, which is technically not a drought because that's a change in the background conditions. So if droughts by definition are acute and periodic, so they have beginnings and ends. If your background conditions are changing, then that isn't technically a drought anymore. That is a change in the background conditions, which would be increasing aridity. And so Navajo has had both going on. They've had acute drought conditions because they've missed precip. They've had just terrible, terrible luck in the last couple of years where parts of the state would go wet and they would just miss out both on winter and summer. And so that's why you see even the drought monitor really hanging on to short and longer term drought conditions. But it's also clearly getting warmer there, which causes its own set of impacts on top of that. So it's just complicated because you can have precip, if we're super lucky and we end up having a run of a couple of years with above average precipitation, which would be great. So that would technically solve drought conditions at one, but it'll be in a warmer climate, which has increased evaporative demand. So the drought can technically go away, but you can still see impacts on the ground, which are really due to increasing aridity. And so I think it's important to kind of tease those things apart. Otherwise they get kind of all swarmed together and it's hard to know when to call a drought off, because it's like a fire alarm going off constantly. You end up ignoring it after a while if you're calling it drought, because then if something more acute comes along, you don't have any sensitivity to it.
Yes. Oh, who knew the weather was so confusing?
Yeah, it's fun.
Okay, we have a question. Can you explain the impact of the El Nino versus La Nina on the monsoons, and is climate change affecting these patterns?
Great question. So the research into El Nino and La Nina really centers on its impact to the winter weather patterns of the Southwest, and they're fairly clear. You can go back in the tree ring records and you can look at the contemporary record, and El Nino events with warmer than average water temperatures in the Eastern Pacific that come on in the summer and fall typically lead to wetter than average winters during El Nino events and drier than average winters during La Nina events. And so that it just shifts the jet stream around. In the summertime during the monsoon season, the impact of El Nino and La Nina, which is really modulated by the jet stream pattern, tends to just go away. And it's because the jet stream retreats north towards the cold air at the poles. And so even with an El Nino or La Nina in the Pacific, it tends to not have much discernible impact on the monsoon season. But there have been a couple of studies that have shown very weak correlations with El Nino and La Nina on the monsoon. And a colleague of mine at U of A, Chris Castro, did some of his dissertation work on this, and it's still pretty much, there aren't too many studies past it that show when you're in a really good mature La Nina in the spring, that tends to help the subtropical ridge, the Four Corners High, build in faster and be anchored in a really good spot. So the monsoon in a strong La Nina spring tends to come in earlier, and its effect basically dissipates by the end of July. So La Ninas lean a little bit more towards earlier monsoons. El Ninos, on the other hand, tend to cause the Four Corners High to be weaker and not move in as quickly, and so you end up having a later monsoon season. Again, it doesn't happen every year, and the correlations are pretty weak. So last summer, there was a very weak El Nino that had fallen apart, and I wasn't super compelled by it causing the monsoon season to be late, but it may have had a lingering effect, and that could be why the monsoon season was such a stinker last year. But El Nino had fallen apart by that point, so it really wasn't even in the realm of the correlations of the past events. So on the climate change part of it, the models are almost evenly split on what the impact is going to be to El Nino and La Nina. So that means we're not really sure. But there's been some research recently that seems like it's on the right track, and I think it's got some pretty strong evidence behind it that the monsoon is probably going to shift towards stronger events, moving back and forth between strong El Ninos and strong La Ninas. And so that could be interesting because we tend to have our strongest responses down here when El Nino is in either a strong El Nino or a strong La Nina phase. So the upside is it could be more predictability for us. It gives us a little sense. We tend to not know what's going on when we're in these weak El Nino or La Nina. So if we're moving back and forth between strong El Ninos and La Ninas, that would give us predictability. The downside is strong El Ninos can be very wet and cause destructive flooding, and strong La Ninas are absolutely hands down the causes of our winter droughts here. Like if you know a La Nina is coming, then it's a very good chance that the following winter is going to be drier than average. And that's really where we're at right now. There's a weak, it's really a weak forecast. It's a forecast for a weak La Nina, but it's a weak forecast in general. So it's not, we have to wait a couple months to see if that's actually going to manifest. I am not convinced that we're going to see a La Nina next winter. The models, again, have kind of gone in different directions. We're probably headed for another neutral event, maybe slightly cool.
Anyone else?
I have another question if nobody else does.
Go for it. Oh, no, please go ahead.
Okay. So, now what was my question? Having a senior moment. Oh, yeah. So what is I don't know, this might be outside your area of expertise, but the long-term forecast for water availability, drinking water, in Tucson, and how much are we dependent on the weather, or do we have enough water underground to hold us for a long time, or is my house going to lose all its value in the next 20 years?
No, it's a really good question, and I'm more talking as like a concerned citizen myself. I have colleagues who work on this, and so it will only be kind of what I can remember of having discussions with them. What I know about the water planning in Tucson is that it's actually fairly progressive, and they've been doing long-term planning for a long time, like well over a decade, and they've been taking climate change actually pretty serious. And so they have quite a few contingencies in place that other places don't. And we have this mixed supply of cap water that they've been banking, and this distributed network of groundwater wells across Tucson that we pull water from. So my understanding is we're not on the precipice in any way, and that there are some really good people in the different Tucson water companies, including City of Tucson, sort of thinking about this. So I feel pretty good about that. I mean, it's they've had real successes with conservation measures here in Tucson, to the point where we've had trouble actually on the wastewater side, like getting water, like the transition to low flow toilets has actually caused problems with sewers not having return flows that are strong enough to get everything back to the water plant. So it's all these like unintended consequences that arise when you're moving in the right direction. Something else kind of falls apart. So everybody I've talked to, there's certainly challenges ahead. The cap water supply is seriously threatened, but Tucson has kind of thought a lot of that through, and I think a lot of the conservation measures. And quite honestly, I've got a friend who works in wastewater, may not be interested to hear this, but Tucson is treating its wastewater to A++ quality. So
that doesn't bother me.
There you go.
So the banking of the CAP water, that's what you see from Gates Pass when you look out to the west. And you think,
that's my understanding. Yeah, Aver Valley is got a recharge field.
Yeah, okay. That's what I wasn't sure what that was, but I thought,
yep. Yeah, they engineered it for percolation. So the Tucson takes its allocation and then tries to drive it into, it still seems like voodoo to me. Like I don't know where it goes, and I don't know if they really know where it goes, but they're assuming they can get it back out.
Yeah. Yeah. Okay. I hope they can.
Yeah, me too.
I say this all the time. I think Susan and I took a, what was it, Citizens Water Academy, and got to drink some of that purified wastewater.
Yeah, what do you think?
Refrigerator. I haven't drunk it yet.
I opened it. A girlfriend came over. We had a COVID distancing dinner, and we split that. That was like a, champagne.
It's like a vintage.
Yeah. Yeah, but it was the purest. I mean, we got to see how the steps they went through to purify the water, and you could see the different colors. It was like, oh, it's so gross, but
it's fantastic.
Well, there are places, London comes to mind, where they've been treating and drinking their city wastewater since like the 80s.
Wow.
Yeah, I think that's right. Yeah. And Payson has been quietly doing it too for at least 10 years.
Yeah, we think of it as a strange concept or even a yucky concept, but there's parts of the world where it's been accepted as normal for decades.
Yeah. I think we will come around as well.
Yeah.
Michael, did I hear you say that the Tucson tap water supply is in serious jeopardy, or did I not hear that right?
No, I'm sorry. I said cap water. It's too close. The Central Arizona Project water, we're at the end of the line, and the cap water itself, Central Arizona Project water, is on the shortage list for the Colorado River water allocation. So it's got a pretty dicey future. But our local water here, I think, is in pretty good shape.
Okay, right.
That's related to snowpack in the Rockies. Why?
Yeah.
That's the cap water.
Yep.
And how big a percentage of usage is, how dependent are we in Tucson on cap water?
We're not even drinking it now.
Yeah, I don't think we're drinking it. Yeah, I think that there was they tried to introduce it. I'm way out of my lane right here, and so there's a lot of fact checking that probably needs to happen. But there was I believe, a time when Tucson Water tried to implement cap water, and it caused all this reactions with the plumbing across Tucson, and caused like this huge backlash, and so they just shut it down.
Yes. Is
that right, Karen?
Yeah, it was real. So it tasted bad.
Yeah, right.
Groundwater. I mean, the aquifer.
And it rotted a bunch of pipes too.
Right. That's what I remember hearing too.
Yeah.
Yeah, I don't remember the details, but I think it was some difference in the acidity maybe.
Right.
It caused pipes to corrode, and a lot of people had major plumbing problems. And there was actually a citizen initiative that voted that said Tucson Water can't just put CAP water in CAP water in our lines. And so that's when the city of Tucson came up, or this Tucson Water came up with the idea of banking it, of just putting it into the aquifer, into the layer of permeable rock, gravel, sand that's under our communities,
And hoping
especially
we
out
can
in
find
Upper
it.
Valley. So yeah, and the idea is they can then extract it later, but it will be mixing with groundwater. So the pH of it when they extract it and the mineral composition will be a combination of CAP water and our native groundwater. So in other words, banking it will not resolve that problem. It just
Right.
postpones it.
So people won't remember what happened last time.
Yeah, Tucson Water is starting its new long-term master plan this entire year. I think it's 2030. And there's sections of it specific to climate change.
Yes.
And they want public input. So it'd be a good opportunity for people interested in being involved in policy matters, water policy, to get on the ground floor.
And Karen, isn't there the Citizens Water Advisory Group too?
Yeah, that was fun. That was great.
Were you on that?
Well, it was a 4-week course.
There's a standing group too that I know some folks on it, and I think that they're the citizens group that engages with Tucson Water on that planning, and they're a great group too.
Yeah, I mean, it's worth getting climate change, I don't even know my own website, climatetucson.com. There's a short story about what's going on with Tucson Water and how to get to their website and how to get involved. So if anyone's interested, check that out. Any more questions? How hot is too hot? I mean, the last we heard was that within, who knows, but Tucson's temperatures could go up 7 to 9 degrees. And our winters will be, our evenings will be warmer.
This is over how much time?
Who knows? I don't know.
Yeah, 7 to 9 would be end of century. So that would be, 80 years out. So I'd say in the next 30 years, a couple more degrees warming are probably pretty likely.
Well, that's a lot.
It is, yeah. When it could turn a 110 degree day this Friday into 113, or it could put the 117 record at great jeopardy, much sooner than later.
Do you know how much it's gone up, say, in the past 50 years?
Yeah, I think Tucson's gone up a degree and a half, 2 degrees Fahrenheit, I believe. And we honestly too, we do have an urban heat island signal in that change as well. So there's a bit of land use change on top of the climate change signal there. Phoenix has like a 7 degree Fahrenheit temperature change, and that is like 90% urban heat island, just because of where that station is and what has happened to Phoenix. It's just crazy how much change they've seen.
Well, any more questions? Hello.
This has been great.
It has been great. He's answered all our questions.
Thank you so much.
Oh, it was really fun talking with you. Great questions.
Would you mind like maybe one email in the future if I think of another question?
Absolutely. As many as you want to send.
Oh, all right.
Yeah, I'm happy to. It's my job, actually.
I see. Oh, okay. Well, then I won't feel guilty about it.
Yeah. It's your state tax dollars at work.
Right. And thank you, Karen, for organizing this. It's wonderful.
Okay. Well, I hope all of you will try to come to the next two. I don't know, trying to do it all in 1 week is kind of crazy, but hey, why not? They're going on. So,
it's timely.
Oh, hello. Do you have questions, please?
No.
Okay.
No. I just wanted to thank you as well.
Thank you. Thank you. I'm glad everyone showed up. So if there are no more questions, I don't see any on the list. We'll sign off. And thank you so much, Mike, for this wonderful discussion and all your graphs.
Fabulous.
Thank you so much. It was really fun talking with you. Great questions.
Thank you.
Thanks,
Right.
Mike.
Thank you.
So much.
All right.
Bye,
See y'all.
everybody.
Have a great night. Stay cool.
Bye.
I'll talk to you later, Mike. Thank you so much.
Okay. Bye-bye.
Who's at his stand?